Hi everybody, welcome to another video in course Algebra, section 2.A, distance and midpoint formulas. Circles. Equation of a circle. Distance formula. Let x1, y1 and x2, y2 be 2 points in the rectangular coordinate system. Then the distance between these points is d equal to square root of x1 minus x2 square plus y1 minus y2 square. Square root of that. So let's just sketch the proof. So we have x1, y1, and there's a x2, y2. And we want to find the distance between them. Let's this one be d. So what we do is we draw lines to the x-axis and to the y-axis. Right. From that point, we draw that, and we will have this. So this, since the point is x1, y1, x2, y2, this is x1, and this is x2. So this distance here is x2 minus x1. Just so that the x2 might be on the left side, so x2 minus x1 may be negative. So I'm going to put the absolute values there to guarantee that this is different between the x values. We have that. Now likewise, this will be the distance of the y values. Here we have y1 and y2. So this distance is y1 minus y2. I put absolute value to guarantee that it's going to be positive, or at least 0. Right. So what we have here is a right triangle, and in a right triangle, the Pythagorean theorem says a square plus b square equal to c square. So with this sketch, we see d square, equal to c square. With this sketch, we have a square plus b square equal to c square. So we have x1 minus x2 square plus y1 minus y2 square equal to d square. And notice that the absolute values square, negative 3 square or 3 square is equal to 9. So we don't really need absolute values to just make it a bracket or a parentheses, if you will. And then we take the square root on both sides. Of course, when we check the square root on both sides, this will be plus or minus. However, the distance cannot be negative, so we only choose the plus sign, throw away the negative. So that, of course, is the distance formula, which is derived from the Pythagorean theorem. That's right. So it's very straightforward. And the nice thing about this is I will have x1 minus x2 or x2 minus x1. This interchange doesn't matter because it's a square. Right. Then we have a couple of examples here. I'll find the distance between these points, so it's very easy. Distance formula. Here we have 1 minus 2, or here I have 2 minus 1, or 1 minus 2. Doesn't matter. okay, I write here 2 minus 1, here 1 minus 2. Like that, it doesn't matter. As long as we have the absolute values. And then when we square it, the absolute value doesn't matter anymore. Right? So, like that. x2 minus x1 minus x2, when we square it doesn't matter. I could just say x2 minus x1 square, y2 minus y1 square. As long as the x go with the x, the y go with the y. Don't switch them. And of course we can just interchange x2, y2, x1, y1. The distance from one point to another is the same in the other way around. So the x minus x square plus the y minus the y square, take the square root. Right, since we have the formula like that, x2 minus x1 plus x2 minus x1 plus y2 minus y1 3 minus -1, so that is 4, 6 square, so we have 4 square 16, 6 square is 36, to just square root of 52. Right. Of course we can break down 52 is 2 and 26, or 2 and 13. So 52 is 2 square times 13. And so we switch. Square root of 2 square is 2, so we just have 2 square root of 13. Right, simple as that. Now find the distance between these 2 points. Once again, it doesn't matter x1 minus x2 or x2 minus x1. As long as the x minus the x, the y minus the y. Right. Let's say x1, y1, x2, y2. Right. x1 minus x2, y1 minus y2. Yeah, so here we have -6 square. It's just the same as 6 square. It doesn't matter. Still 36. Right, so x1 minus x2, y1 minus y2. Alright. So 0 minus, so that's 1 square. 2 minus 4 minus 2 square. So I have 1 plus 4, so just square root of 5. Right, so just like that. Next, we have the midpoint formula. So the midpoint formula, if we have a line segment, let's say we have x1, y1, and here's x2, y2. Then the coordinate of the midpoint is given by this. So pretty much we take the average of the x for the x coordinate and the average of the y for the y coordinate. So that, of course, you can take, so that the average of the x values and the average of the y values. So it's very straightforward. So find the midpoint, and also when we talk about the average, x1 plus x2 or x2 plus x1 is the same thing. So average of x, average of the y. Average meaning we add them up, add the two values and divide by 2. Alright, now find the midpoint of the line segment here. So x1, y1, x2, y2, and the midpoint x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we have negative 7 over 2, and negative 10 over 2 is negative 5. So we can just pretty much sketch so negative 8 and negative 4. I'm just going to sketch negative 8 and negative 4, and then 1 and negative 6, 1 and negative 6. So it's like that. So the midpoint between 1 and negative 8, that's going to be negative 7 over 2 or negative 3.5, and between negative 6 and negative 4 is negative 5. So just the average or the midpoint on the x-axis and midpoint on the y-axis, average of the x and the average of the y. Right. Next we have equation of a circle. Definition: a circle is the set of all the points in the plane that are equal distance to a fixed point called the center, and the fixed distance is called the fixed distance from the center to a point on the circle is called the radius. So here we have a radius. Here, that be r. So that distance will be constant from the center, right? In this form, we will let the center be h and k. So the coordinate of the center is h and k. And the definition says that the distance from the center to any point on the circle is equal to constant. So in that case, we can just say this point here, a point on any point on the circle has a coordinate x, y. So what we do is we start with the distance formula. Distance between these 2 points is equal to a constant r. So that's what we said. x2 minus x1 square plus y2 minus y1 square under square root equal to r. So just the distance formula. And after that we square both sides, and here we have the standard form of the equation of a circle. The center is h and k, and r is the radius. Right. So pretty much that's what we have. Now I'll find the center and the radius for the following function. So here I just compare that with the standard form of the equation of a circle. So from here we say h is equal to 2, because that x minus minus 2 is h. Y and y, we have 1 equal to negative k, so k equal to negative 1, right? 1 plus 1 minus, so we have plus 1 equal to minus k, so k equal to negative 1, and r squared is equal to 5. Taking the square root on both sides, we have plus or minus square root of 5. However, r is the radius, is the distance, cannot be negative, so we choose the positive. So with that, we have the center at h and k, which is 2 and negative 1, and the radius r is equal to square root of 5. So it's straightforward. The next one is not straightforward. We don't have the equation in the standard form, so we try to turn this into that form first, this form, before we can find the radius and the center. Alright, so what I do is try to group the x together, the y together. X squared minus 4x, so x with x, y with y, and then plus 3 the number on the other side, so x's together, y's together, and the constant to the other side. Right, what next is we will do a complete square. We're going to add something here. And since we add on one side, we have to add to the other side as well. Right. And remember, completing square, we will take half of the middle number, and then we squared half of that square. Negative 2 squared is 4, so we're going to add 4 on both sides, and then we take half of this number, and then we square and add on both sides. Right, and the complete square will be just x minus 2 square for the first one, y plus 3 square, 3 plus 4, 7 plus 9, 16. So we have the standard form of a circle. Right. And the equation of a circle will be, we have the center, let's spell it right, center h and k, and this one h is equal to 2 and k equal to negative 3, and the radius r squared 16, take the square root of that, plus or minus 4, but once again we only choose the positive. So if the radius is equal to 4, the center is at 2, because h is 2, k is negative 3, so the center is at 2 and negative 3, radius is equal to 4. Right, so from the equation of a circle, whether it's in the standard form or not, we can find the center and the radius. What we have here is we have the radius and the center. Now we're trying to write the equation of a circle. So we have the center negative 2 and 1, center of the circle is at h and k, and the radius is 2. The equation of a circle, x minus h square plus y minus k square equal to r square. right? From here, we can say h is equal to -2 and k is equal to 1. I can substitute into the equation here x minus -2 for h and y minus 1 for k equal to 2 square. So that minus negative, that x plus 2 square and y minus 1 square equal to 4. Right, so simple enough. When we have the center and radius, we can write the equation of the circle. Or when we have the equation of the circle, we can find the center and the radius. And on this question, they ask us to sketch the circle and then find the domain and range. So simple enough. The center is at -2, x equal to -2, y equal to 1. So the center is here. And then the radius is 2, meaning we go every direction 2 units. So just try to sketch a circle. Just a sketch, not going to be perfect. Right. So the point here is the center is at -2 and 1, and we go 2 the radius every direction. So we go 2 up, 2 down, and 2 left, 2 right. With that, from the x values of -2, we go 2 to the left, 2 to the right. So that gives us the domain on the possible x values would be from -4 to 0, including the -4 and 0. Right? -2, 2 units to the left is -4, 2 units to the right is 0, so -4 to 0, including the point, because there's no empty circle here. So all the x values is all the x values are the domain, and then the range, all the y values from 1 go up 2, that would be 3, without 2 would be -1. So we go from -1 to 3, from -1 to 3, smaller to the bigger values. Right? So that is the domain and the range for the graph of the function, of the graph of the equation of circle. It is not a function, obviously. It fails the vertical line test. Right? But that's all we have for section 2.8. Thank you for watching, and see you in another video in college algebra.